Okay, let's get this started then. So welcome everyone to Bootcamp, and this is the beginner's guide to Android talk. So I hope you guys are all in the right place. As Tim ably said in the introduction, today is all about kind of getting you up to speed so you kind of know everything you need to know so you can get the most out of I/O. So this talk is really pitched at someone who kind of knows what Android is but has never developed for it. My name's Nick Butcher. I'm a developer advocate out of the London office, and I work on Android. I love writing Android apps, and I hope by the end of this you will too. And we've also thrown out some hashtags here so you can join the conversation and chat about what's going on. So this is the speaker meter. So as Tim said, this is a kind of experiment this year, and we really hope you can use it. So I'll leave that up there for a minute. There's also a short code just there. So if you haven't got a QR phone camera app, you can type that in. I'll also throw this link up at the end. If you want to wait to the end to leave your feedback, that's absolutely cool. So while people are snapping that picture, just want to get a quick idea of who's in the room. So could you put your hand up if you have written an Android app before? OK, cool. And put your hand up if you've kind of had an idea for an Android app but never had the know-how to actually write it and execute it. Excellent. So you guys, this is going to get the most out of this talk, I hope. For some of the people who are more experienced, hopefully you'll pick up a few tips and tricks along the way. But I'd really recommend you go to the Android Best Practices lab later on today, which is going to really teach you some really good techniques. And also, we're going to be running an Introduction to Honeycomb lab later on. So if you fancy getting up to speed with tablet development, then that's the place for you guys. OK. So today I'm going to talk a little bit about what Android is and what the Android platform is and how you develop for it. I'll talk about writing your first app. So what is an app? I'll go through the anatomy of what it is that makes up an Android application. I'll talk about the ways you'd go about building it. Then I'll go on to talk a little bit about some of the unique ways that Android lets you surface your content, access hardware sensors, and then how to make not just a good app, but a great app. I'll then go on to talking about the tools you can use to build these applications, and finish up by going through the process for publishing your application on the Android market. So Android, it's a bit of a juggernaut. It's in the kind of newspapers and tech press all the time. 170 plus devices, 100 countries, and shipping 350,000 devices a day. That's kind of like such a kind of staggering number to me, I feel. My colleague was stood here last year saying, proudly that 60,000 devices a day, and now we're at 350,000. So you can think of like the slant of the graph and the trajectory they're on. A little bit of mental arithmetic for you. That's over 1 million devices every 3 days. This really speaks to the opportunity out there and the reach you can have in writing an application and shipping it. The same thing, that kind of size of opportunity can seem a bit daunting as well when you think of the variety and number of devices out there. But the great thing about writing for a platform rather than for a device is that every device which has the Google services, so that's like Android Market and Gmail and Maps, for example, and everybody wants those, has to pass a compatibility test suite. This guarantees that any app written against our SDK will run on those devices. So it's our way of kind of making it easy for you to write to the platform rather than have to worry about individual device characteristics. So we build in tools to help support many different screen sizes and resolutions and form factors and hardware variety, and the system lets you take advantage of those where they're available. Android Market also helps you out by filtering based on what the phone that the application is running on supports. So yeah, if you write to the platform, you don't have to worry so much about the underlying phone. That said, the platform isn't a static thing. You're probably aware that the Android team's hard at work releasing new platform releases every kind of 3 to 6 months. So we've just had Honeycomb came out for tablets not so long ago, and the end of last year, Gingerbread for phones. We'd advocate always kind of targeting the latest and greatest so you can take advantage of all the new shiny APIs that get released. But we can teach you techniques to gracefully degrade your application. So if certain functionality isn't available in an older platform, you can gracefully degrade and perhaps use another technique. So for example, multi-touch got introduced at some point. So you can detect at runtime in the application if the device you're running on supports that, and if so, enable a multi-touch kind of control. Else, you can fall back and perhaps offer buttons or something to offer the same functionality. So, writing your first app. So an Android application is really kind of a series of components. It's all about kind of loosely coupled components within Android. And the thing which holds them all together and makes them into an application is the Android manifest file. So I'm going to take you through what are these components that make it up. So the four major ones being the activity, service, content provider, and broadcast receiver. I'm going to take you through what intents are and why they're so key to the Android system, and then come back around to the manifest and how you string these things all together. So first up is the activity. This class is how you write your user interface. So a single activity defines a single screen. Activities are kind of independent, and you string a series of these together to form a cohesive whole or a whole application. It's possible to invoke these activities from within your application, but also from within other applications. So in that way, you can expose functionality from your app to other applications, and you can borrow functionality from other applications or from the system within your app. Every class that you write for an activity should extend the activity class, and you get a bunch of methods there to help you do your UI. The next major component I'll talk about is the service. So a service is what does the heavy lifting or the majority of your processing in your application. So it's going to run all your kind of long-running tasks or and so on. So a service doesn't offer any user interface, but it kind of is the kind of logic behind that. Other components can bind and interact with your service. So a great example of this is if you're going to write a music player application, for example. You might write the user interface as a, well, you will write the user interface as an activity, offering kind of skip, play, pause controls, for example. But then you would use a service to actually control the music playback itself. So if a user starts playback in the activity and then leaves and goes and checks their email or browses the web, the service carries on running in the background and keeps on playing the music. The next component is the content provider. So a content provider says it manages a shared set of application state. So really, it's kind of a facade on all of your persistence of any data. It provides a consistent interface to the Android system and to the rest of the world on how to interact with your data. So there'll be that querying, storing, updating. So it exposes CRUD-type operations. It's also a RESTful interface. So every unique entity has a URI associated with it, and then you can perform operations upon those URIs. So underneath this facade, you can back it with any kind of store. So commonly, it'll be a SQL-like database, but equally, you could back your content on the file system or on the web. It's up to you how you implement it. You just expose this consistent interface so the system knows how to talk to it, and other apps know how to talk to it. So content providers allow you to expose data from within your application to other applications into the system. So for example, the system makes extensive use of content providers in the search infrastructure. So when on your Android phone, you hit search, and you can search through the data on the device. It's because of this consistent interface that it knows how to search an application you've just installed from market and how to query it. Equally, the system exposes its data to you as a content provider. So in your applications that you write, you can do things like query the contacts system or the call log or the music on the device or the pictures on the device because of this consistent interface. And the next major component is the broadcast receiver. So as I mentioned, Android applications are kind of loosely coupled components talking to each other. The way to listen to things, to messages between each component is the broadcast receiver. So you can respond to system-wide messages. So if a text message comes in or a phone call comes in, a message will be broadcast to the system, and apps can respond and offer functionality based on that. There's two major types of message that can be broadcast. First one being the normal broadcast, which is delivered kind of asynchronously to all receivers in no guaranteed order. Or there's an order broadcast, which you can set a priority in which the messages will be sent out. So an example of this is if you want to write your own message for handling an SMS, for example, your own application for handling an SMS. You might want your application to handle it rather than the system's built-in one. So you can register with a higher priority, catch the message that a new SMS has come in, and say it's handled so it doesn't carry on propagating. Broadcast receivers can be registered to listen for certain messages, either statically, so you define it in the Android manifest, or at runtime, so you can dynamically start and stop listening as you wish. Broadcast receivers are just that. They're just listening for messages. They shouldn't really be doing lots of heavy lifting and processing. So once you've kind of listened out for a message, you want to hand off any long-running tasks to a service to process. So those are the four major components. Now, intents are the magic that kind of glues this all together, really, if you will. There's always an intent for launching and talking to different components in your application. So when we say a broadcast receiver listens for a message, that message itself is an intent. Now, these intents can be explicit or implicit. So an explicit intent is like an explicit message. It says exactly who I want to deliver something to. So if I have an application made up of two screens, screen A and screen B, and in screen A, I click a button which should take me to the second one, I can explicitly address it to launch screen B. So clicking that invokes screen B, and it launches. More interestingly is the implicit intent system. So just by describing something you would like to achieve, so an action you'd like to perform upon some data with some extra metadata, and then handing over to the system and asking, is there anything installed on this device which can handle this action on this type of data? So by standardizing on a set of common actions, so I want to view this data, I want to send this data, I want to edit this data, you can have lots of different and unforeseen applications handling a standard message. So a great example of this is photo sharing. If I write an application which kind of can take photos and then share them, I could think about all the possible ways that places I want to share that photo to. I could write in Facebook sharing, Twitter sharing, Buzz sharing. But more interestingly, I could just say I have this data of type kind of photo, and the action I want to perform on it is share, and hand over to the system and say, hey, what's installed that can handle this intent? And then the user could have installed an obscure or kind of different social network or whatever site that they want to share it to. And that application can then say, hey, I know how to handle a share action on a picture. Let me do it. So by doing this kind of standardization on actions, you kind of can have this unintended uses of your data. It's great. One of my favorite examples of this is an application called Barcode Scanner. So Barcode Scanner has said, hey, I've got this kind of great use case of scanning barcodes, and it's really helpful. But wouldn't it be even greater if I can offer up this functionality to other applications? So what they did is they standardized on an action and published this action out on their website. And now other applications are free to invoke this application. So the way they do that, so for example, this is one of my favorite grocery apps in the UK called Ocado. So Ocado wanted to offer the ability to add groceries to your basket via scanning a barcode, but they didn't have to write their own barcode scanning software, which is quite complex. They simply click on the barcode button, and this will invoke the barcode scanning application, which will do the work of scanning the barcode, and then hand back to the grocery app to add it to your basket. So it's a pretty complex task, I guess, scanning a barcode, but it can be achieved very simply for the calling application. So the grocery app just has to include some very simple, not a huge amount of code for quite a complex interaction in order to accomplish it. So going through this is one of those explicit intents I mentioned earlier. So when we create the intent, we know exactly the action we're trying to perform, so this Android.scan action. And we set the package which we know will perform it. We can then send some extra metadata. So we're saying here that we want to do a QR code type scan. We then do a call to start activity for result, passing in that information we just set up. So what this does is it's going to start a component written in an entirely separate application and run it. Now, to the user, this is completely transparent. So I just think I'm in my grocery app. I just hit a button, and a barcode scanner comes up. I've got no idea that the developer of the grocery app didn't have to write this barcode app. It's kind of seamlessly integrated. So the user does the work, takes a photo of a barcode, and finishes scanning. And the result gets returned back to the calling application. So here we can check some things like make sure that it completed successfully by checking for the result OK. And then grab back from the intent the result. So this is the actual code that they scanned. So in very few lines of code, you've got this quite complex interaction. all powered by intents. So wrapping those back up together, we're coming back to the Android manifest. So the manifest declares all of the components within your app. So this is where you're talking to the system. So when the user installs your apps, you're saying, hey, this is what my application is actually made up of. I have this many activities, this many services, this many content providers, for example. It's also an opportunity to declare the features that your application requires. So if you need internet, for example, or if you require GPS hardware, then you can use the Android manifest to declare there and then what your application requires to run. So the system knows how to run you as well. You can also state what versions of the Android system you require for your application to run. More interestingly, you can actually say the lowest version you require to run, but you're also aware of a higher version. So you can set a target SDK of, say, the latest and greatest, say, Gingerbread, but I also run compatible all the way back to, say, Cupcake. So by doing this, you're essentially completing a contract saying, I won't use any of the newer APIs when I'm running on an older version. So when you're writing your app, it's really important to remember that you're running on a multitasking environment. Mobile phones and tablets are kind of multitasking devices with lots of things going on at once and often quite memory constrained. So users will switch between your applications all the time. The system's going to run low of memory. Calls are going to come in. So your application, when you're writing it, needs to be aware that you're in this kind of busy environment and be able to handle it properly. The system will call into your application with a series of kind of callback events to let you know when these events happen. So it's really key to remember that at some point, the system will kill your application. When we were writing our amazing apps, it's kind of really kind of nice to think that the user's going to sit there with full concentration and just use the app as you kind of intended, and then happy days, finished, and they're done. But in reality, there's going to be 101 things going on at the same time. So the key thing, I'm going to walk through this activity lifecycle in a bit more detail, but the key message is to respond and work with the system lifecycle, and make sure you save your state, for example, so that if the user comes back to your application, it has been killed by the system, they don't get surprised and say, hey, where's my data? I was in the middle of something. So when you launch an activity for the first time, and the activity is created, you'll get a callback into your applications on create. This is kind of similar if you've done some Java programming to kind of your main method. It's the first entry point, and it's your first chance to do any kind of setup and initialization logic. You then get a callback into the onResume method, which is just before you're about to become foreground, and then your activity will be running. So if while your activity is running, say a call comes in or they switch to another application, the system will then let you know that that's happening to your application and it's no longer going to become foreground. So we get a call back to your application's on pause. Now this is key, like in on pause, you definitely want to be saving all your state so that if a user comes back to your application at some point, it's still in the state that they thought it was in. There's nothing worse than kind of, you know, I was playing a game or something like that, and then a call comes in, and then I forget I was playing the game, and I surf the web, and I come back to the game, and it's kind of, I've lost all my progress, and you have to start again. I mean, that's an example of someone not using on pause properly to save their state. So if after the calls come in, and the user just comes back to your app straight away, you're going to get a call back to the onResume, so then you can just make sure that the application's in the right place. But if they don't come back to it, so they go off and surf the web or whatever, and the system starts running low on memory, it's going to kind of kill your application, and it's going to reclaim some of that memory. It's going to stop you. So the user should be completely unaware that this is happening. So if your activity gets destroyed, and then a user later comes back to launch your application, it should be like it was just sitting in the wings waiting. So when they go through the onCreate again and onResume, you need to be grabbing the state that you saved in onPause to set it up like it was just waiting for them. So next up, I want to talk about some of the unique ways that Android lets you surface your content to the user. Android's got a really great notification system. So you can throw up notifications up into the top bar, as I've highlighted here. And you can show like an icon. You can buzz the device or flash a light if it has one. And you can also have some scrolling text going across. Or if you pull the tray down, you can get some expanded information. So these unobtrusive notifications are fantastic, I find, for kind of these busy lives that we lead with 500 apps installed and things. I don't want to be going into my app all the time to check it. I want the app to let me know whenever something happens. So it lets you kind of create event-driven kind of models so that the user can come back whenever something interesting has happened. You can also provide quite a lot of information through them. You can provide custom views in this expanded tray. So if you want to have your application show a progress bar or something to let the user know something's going on. You can also deep link to a place within your application with setting one of these intent objects, a pending intent, onto the notification. So it doesn't have to take them just to the front screen of your application. It can take you right in there. Widgets are another strong feature of Android. So many times I'm using my phone and kind of, you're bored or on the bus and you're just kind of playing around on the home screen. By letting you put your application's data right there on the user's home screen, it stays kind of forefront in their mind. You can have the data on the widget updated regularly, so it doesn't have to be just static information. You can update it when events happen, or just on a time basis. You can also offer multiple widgets for your application. So one application can have a large widget, a small widget, a widget to show this type of information, this type of information, and you can have interactivity. So this music player widget, for example, lets the user kind of play the music or skip the track right from the home screen. So it's a great way to drive user engagement. We find applications which have widgets included in them have high use rate. People kind of keep on coming back to them and don't uninstall them. And people love them. They're fun. And next up, I want to talk about cloud-to-device messaging. So this lets you reach in from your servers kind of right down to the Android application and kind of send it timely messages. You can send like tickles, it's got a very small payload, but it's very timely and very fast delivered. So you can use this to kind of push messages down to the device. So your application doesn't even have to be running when you want to send a message to it. If it's not running, the system will wake up your app and deliver the push message straight to your application. And then it's up to you how you respond. So there's no predefined UI. You don't just get a modal dialog popping up or whatever saying something is updating. It's up to you. So if, for example, you're writing a messaging app or, say, a news app, you can have your servers ping the Google Cloud-to-Device messaging services, which will reach down to the device and wake up your app and let it know there's some new content. Your application then wakes up and can then retrieve that content straight down from the web server and let the user know, perhaps using notifications. Because it's built on top of the existing Google messaging services, so the same thing that Gmail and Google Talk uses, there's minimal effect on the battery. You're not keeping other kind of persistent channels of communication open between the device and the cloud, so you're not going to be hammering the user's battery. OK, so we talked about some of the cool features in Android. I'm going to talk about how you can go about building them to create your app. So building your app's UI is kind of very important. So the user interface is a hierarchy of widgets which extend the view and view group classes. So you can define these in code and create them all in code, but it's much cleaner to define your layouts by XML. So on the left here, we have an example of a layout. So this has got a linear layout, which includes a label and a button. So very simple, very clean to define your layout. And then the system will kind of inflate that layout into a series of these hierarchy of these objects. So Android, by default, comes with a palette of widgets which you can use, so like the linear layout, the text view, and the button. But you can also create your own components if you need some richer controls or combine existing ones into a kind of a custom component. So once you've defined your layout, you can then tell your application how to use it. So in an activity below, we're calling the method setContentView and passing it an identifier. So it says here r.layout.main. So imagine the XML file above was called main.xml. Then the call below is telling the application, this is the layout file I want to use for my display. So where would that file live? So anything that's not code lives in a res folder in your Android project. So in here, we have a folder called layout, and there's that main.xml. So right here, you can define your application's layout. More interestingly, the resources folder lets you provide qualifiers to provide different versions of resources for different configurations of device. So just beneath that layout folder on here, you see there's a layout-port. What this means is we're specifying a completely different layout for a device when it's running it in portrait mode, that means, rather than the default one in layout mode. So at runtime, the device will know that what configuration it's running in and grab the right resource appropriately. This is really powerful when you think about all the different, so when you look at the different qualifiers that you can use. So as well as orientation, you can use the density of the screen that you're running on, the size of the screen. So if you're running on, say, a small device or an extra large device, you can have different layouts or different image assets. Or even if you're running on a different language of the device, then you can provide different strings, for example. So looking out there, what devices are on the market, there's a huge variety in kind of sizes and shapes and capabilities. So you've got your tiny little phones to regular phones to tablets, even up to kind of Google TV. So you have to think about these devices and how your applications will run on them. So supporting multiple different screen sizes, there's lots of techniques built into the Android platform that will help you out with that. So one technique I'd definitely advocate using is the relative layout. So don't kind of size things in exact pixel dense dimensions. Using relative layouts, you can say, I want this kind of to the left of this component, and this to the right of the component, and this taking up the rest of the room. So you're not kind of so constrained by fixed dimensions. You can use attributes such as wrapping content and matching the parent and weights. Say this wants to take up a third of the screen, and this to take up 2/3 of the screen. And this will help you to keep your layouts to scale appropriately, no matter what the device. Another great platform feature is the DP, or the Density Independent Pixel. This lets you say, I want this to be 100 pixels when it's running on a medium density screen, for example. But if I'm running on a super high density screen, I want it to be sized slightly larger. So the physical size of it will be the same, even though the pixel size is larger. So techniques like this, kind of think web-style development. So you have kind of fluid layouts that will scale no matter what the size window it's running in. You can provide, using the resource framework that I talked about in the last slide, you can provide specific density assets. So on a high-density screen, like say the Nexus S, you can provide a higher resolution image, so it looks great on that screen. Whereas on an older G1, you might want to provide a lower res image, so it's not taking as much size. You can use the resource qualifiers to provide specific layouts for different devices. So if your application is running on a Motorola Zoom, for example, you can use a layout -X large to provide an optimized layout for that larger device. Another great technique is a 9-patch drawable, which is a system of specifying which parts of your image assets can be stretched and which should be rendered as is. So this lets you say, create a text box by saying the corners should be rendered exactly as they are, but the middle bits can be stretched out. While I'm here, I'd say if you're interested in learning some great techniques about this, you should go along to the best practices, Android best practices code lab later on today, which is going to go into much more detail about how to use these techniques. So one of the most interesting things about writing Android applications at the moment is the devices they run on have these fantastic hardware sensors. So you have access to cameras, to accelerometers, G meters, light meters. So all of these kind of really fancy kind of sensors that haven't been available to us in software development on kind of desktop devices enable all kinds of interesting applications to be written. So using the Android system, you can use the sensor manager to find out what sensors are available to you, to your application at runtime. You can then register listeners to listen out for updates to that. So this, you get hold of a G meter and listen for changes in orientation, for example. So yeah, really think about what sensors are available in devices now and what's coming, and how you can really use that to make a really kind of compelling application. Another Android strength is its ability to do background tasks. And when I talk about background tasks, I don't just mean kind of multitasking. I'm not talking about listening to music and reading your email. I more mean the system's ability to accomplish a task without any interaction from you. So you can use the alarm manager to schedule your application to wake up and perform an update without the user having to interact with it. So think about if you write a news application or something which grabs content from the web. There's nothing worse than pulling out your phone, opening an application, and seeing a modal loading dialog, or nothing's happening. Or if I pull out my phone and I have no out of coverage, and it doesn't let me even get access to any items. It's so frustrating. Especially because there's no reason for it. using kind of background tasks and periodic updates, your application can wake up in the background, grab content, so it's right there, ready to go, fresh for the user to use when they want to. So this is great. So it's available offline, and it's always kind of up to date. There's another point. It's one of my favorite features of the system that you also use inexact alarms. What this means is you can, you might be worried that if you have 50 apps installed on your device, all doing this kind of waking up in the background and checking content, that your device is going to be awake most of the time, it's going to hammer your battery. But the system gives a system called inexact repeating alarms, which will actually phase shift your alarms to all coincide and go off at once, so that it minimizes the effect on your device. So be kind of friendly to the user. Next up, Android makes it really easy to make an accessible app. So using things like setting the content description on your content works well with the kind of screen reader technologies. Android also fully supports navigation via D-ball and trackpad. So as a developer, you have to be aware of how to implement this. So setting appropriate drawables that respond to the states when a controller is selected by the D-pad to kind of indicate that selection. I'd definitely recommend you go to the new kind of best practices on accessibility section and read up on how to make your app accessible, or better yet, try it. If you install the TalkBack application, you can try navigating your application in kind of accessible mode and see how it is for a kind of visually impaired user. Next up, I'll say that there's over 150,000 applications in the Android market, 150,000. So how do you stand out? I mean, the way to do that is to signal quality. So using the techniques we talked about before, this is how you kind of like get users to realize your app is well made. So work with the activity lifecycle. Make sure your app isn't kind of dumping the user's state when it kind of gets killed off by the system. Offload any long-running tasks into the background so that using a service, so that the user interface stays buttery smooth. Users have a very low kind of tolerance for any latency in the user interface. So make sure that any kind of long-running task or processing isn't happening on the UI thread that you hand off to the background. What's more, listen to your users, have a conversation with them. The Android market offers them feedback on your application, so you can leave comments on your application to let you know what they think of it. Sometimes they're quite colorful. Better yet, you can offer your own feedback mechanisms. So if you set up your own kind of forums or kind of Stack Exchange or some kind of technique for having a feedback mechanism so your users can say what's working for you. You know, as the writer of the app, you know exactly what the functionality is and how to use it, but you might not realize that it's not obvious to some of your users. And to that end, work with a designer. I'd always advocate. As developers, sometimes we're very keen to run 100 miles an hour and get as much cool functionality into an application. But if your application isn't usable or aesthetically pleasing, your users might not find it or keep coming back to it, so it might be wasted. Cool, so to put together these wonderful applications, here's the tools you can use. First up, you want to go and grab the Android SDK. So this SDK will have all the kind of tools you need for building your applications, as well as things like the emulator, which will let you run your application without the device, and tools for signing your application when you come to upload it. There's a very polished toolchain built around Eclipse, which is going to make your development life really easy. So if you install Eclipse and then grab the Android Development Tools plugin, this is an Eclipse plugin which will make it really easy to build your code against the SDK, to deploy it onto a device or onto the emulator, and interactively debug it. We do support other tool chains as well, so IntelliJ or just using Ant, for example, to build is completely fine, and lots of people like that. But for new people getting up and running, Eclipse is definitely going to be the kind of path of least resistance to getting going. Once you have the ADT installed, you can use the SDK and AVD manager to kind of grab all the latest versions of the platform. So when we release a new version of the platform, so when Gingerbread came out, for example, we'll release an update to the SDK so you can build against these new APIs that have just been released. And so, again, if you're getting started, these slides will be online. I'd advocate you go towards the full guide to getting going. It will walk you through the process of getting up and running. Cool, so you've built your amazing application, implemented your idea, and you now want to share it with the world. So here's how you publish your app on Android Market. it couldn't be simpler. You just develop your application, register, and then hit publish. So if you go to market.android.com/publish, you can create a developer profile and sign in with a Gmail account. And then there's a one-time $25 fee to gain access to the market. This is just to kind of prevent spam applications. So when you sign up, you agree to the developer distribution agreement, which kind of sets out the agreement between yourself as a seller and Google. And then if you want to sell your applications, you can also create a checkout market account, which will enable you to sell their apps and get revenue for it. So once you've signed up, you just log in, and it's a self-service process to upload your application. There's no review process at all. You kind of hit upload, and your application is live to the world. Google does perform a kind of retrospective takedown of some applications. So if you're, for example, if someone infringes on copyright, and that gets reported back to us, we will take down the app. But there's no review process. So as soon as you decide to listen to the user's feedback and kind of fix a bug they experience, you hit publish, and within minutes, it's live and updating for all your users. So the maximum application size you can set is 50 megabyte, and that's entirely hosted by us. And then the download will be accessible both on the device and on the recently launched Android Web Market. So the Web Market, if you've not used it, is a fantastic tool. Not only does it kind of expose all the great applications you can see on your device, but it's also good for using traditional advertising techniques. So you can drive any existing web traffic you might have to this place on the web, so they can then kind of discover your app and install it straight from the website. To this end, we let you provide kind of high-res promotional images and videos onto your listing so that users can see immediately how high quality your application is and get an idea of what using it will be like. In addition, as a publisher, you can log into your publisher account and see any application crash reports. So if your application encounters a bug on a certain device and the user hits report, you can see the complete stack trace right in the web browser, so you can immediately keep on top of any kind of crashes or stability issues you might have. We've also launched lots of application statistics for your application, so you can see what platforms your users are running their application on, and also what languages they're in. So you can use this information to improve your app. Say if you find out that you have lots of users in a certain country, you might want to localize into that language. When uploading your app, you can also target quite specifically your audience. So in the publisher site, you can set countries or languages you want to target. So say my UK grocery app is only available to UK users, so they can restrict it to only be available to people using Android Market in the UK. Similarly, you can target based on hardware availability on the device. So if you write an application which requires GPS or telephony or a level of OpenGL, in your Android manifest, you specify through the user's feature tag that you require this attribute, and then Android Market will know not to offer your application to devices which don't have that functionality. So that was a crash course in what an Android application is, how you go about writing it, some of the unique features that you have available to you on Android, and how to make an awesome app. I hope that was useful to you, and I do advocate you to kind of go along to some of the code labs today where you get a chance to actually get your hands dirty and try out writing applications for the first time. Do please fill out the speaker meter and let us know what you think of the sessions. Right, so we have a bit of time at the end. If anybody has any questions about writing an Android app, you can go for it. Yeah, we're going to be on the IO Bootcamp site after the event. Anyone else? Cool. Well, thank you very much.